In this lesson, we're going to learn about Pythagorean Theorem. Now, Pythagorean Theorem is a theorem that will help us find a missing side in a right angle triangle. And a right angle triangle is when we have a triangle that has one right angle. And in right angle triangles, you're always going to have two sides that are smaller, and they're the two sides that form this right angle here. The longest side in the right angle triangle is always opposite of the right angle, and this side has a special name. It's called the hypotenuse. So again, the hypotenuse is always the longest side in your right angle triangle, and it's always opposite of your right angle. Pythagorean theorem states that when we have a right angle triangle, the square of the length of the two smaller sides always adds up to the square of the hypotenuse, the length of the longest side. And here we have a diagram just to show this. So if we have this length here, and that's 3 units, the square of 3 units is just 3 times 3, which is 9. And just to visualize this, that's the same thing as if we drew a square with a length of 3. The area of that square is 9. We would just do 3 squared to find the area of this square. Now the length of the bottom side is 4, and the square of that, 4 times 4, is just 16. So if we drew a square with the side length of 4, the area of that square would be 16. So Pythagorean theorem states that the square of the two smaller sides will add up to the square of the longest side. And using our diagram, if we drew a square on each side of the triangle, the area of the two smaller squares is equal to the area of your biggest square. And that works because finding the area of a square is the same thing as squaring your side length. Because to find the area of a square, you're just taking your side length and multiplying it by itself. You're squaring it. So let's just check to see if it works for this triangle. The side length here is 3, and 3 squared is just 9. The side length here is 4, and 4 squared is just 16. And when we add those two together, 16 plus 9 is in fact equal to 25. And that is the area of this square on the longest side. And that doesn't just work for this triangle, it will work for any right triangle. So if I even made this bigger, this side length here is 6, and 6 squared is just 36. And this side length at the bottom is 8 units, and 8 squared is just 64. And when we take 64 and add 36 to it, so we're taking the area of the two smaller squares, we will get 100. 64 plus 36 is 100. And this only works for right angle triangles. So on the right here, we have this triangle. There's no square in one of the corners of the triangle, so this is not a right angle triangle. And if we took the square of each smaller side, so we have a side here of length 7.1 and a side at the bottom of length 81, if we took the square of those two sides, we shouldn't get the square of the biggest side. So the square of 7.1 is 50, and the square of 9 is 81. 50 plus 81 does not give us 149, which is the square of this longer side here. So Pythagorean theorem doesn't work for this triangle because it doesn't have a right angle. It's not a right triangle. Pythagorean theorem only works for any right angle triangle. So we do have a formula we can use for Pythagorean theorem, and remember, Pythagorean theorem will only work for right angle triangles. And our formula is a squared plus b squared is equal to c squared. This will help us find a missing side in a right angle triangle. So when we have a right angle triangle, the two smaller sides are a and b. These are the sides that will be part of your right angle, one of the arms of that right angle. And the side that is opposite of your right angle is C. That's your longest side in the right triangle, and that's called the hypotenuse. So we can use this formula to find a missing side. So let's go ahead and do that in this example. Our formula for Pythagorean theorem is a squared plus b squared equals c squared. And I'm just going to start off by labeling this triangle A, B, and C. C is already labeled for us. That's the longest side in this right triangle, and it's always across from the right angle. And the two other sides is A and B, but it doesn't matter which one you label as A and which one you label as B. So we can just substitute the lengths of A and B into the equation. So this will be 4 squared plus 3 squared is equal to C squared. And to find the missing side, we can just solve this equation. So we can just do these calculations, 4 squared and 3 squared. So 4 squared is 16, 3 squared is 9, and that's equal to C squared. And we can add 16 and 9 together. We'll get 25 is equal to C squared. Now to isolate C, we need to get rid of this square, this exponent of 2. The opposite of the exponent would be the square root. So we would need to square root both sides. And when we square root both sides of the equation, C is just equal to 5. So the length of C is 5. So now I want you to go ahead and try this question on your own. We're looking for the length of this longest side, the hypotenuse. So you can pause the video and then come back when you're ready to check the answer. So here's my solution, and you may have labeled your triangle a little bit differently. As long as C is the hypotenuse, it's across from your right angle. So I use Pythagorean Theorem, a squared plus b squared is equal to c squared. I substituted the two smaller sides, 5 and 2, so I did 5 squared plus 2 squared, and that's just 25 plus 4. When we add those together, we're going to get 29, and to get c on its own, to isolate c, we need to use our square root. So when we square root 29, you will approximately get 5.39. And you can see that that is the longest side in this right triangle. So that's how you would use Pythagorean Theorem to find the missing hypotenuse in a right angle triangle. We can also use Pythagorean Theorem to find the length of one of the smaller sides in the right angle triangle. As long as you have 2 out of the 3 sides in a right angle triangle, you can use Pythagorean Theorem. So our formula is a squared plus b squared, and that's equal to c squared. And let's just label this triangle. This time we're given c, that's the hypotenuse, and it doesn't matter which one is a and b. And now we need to substitute these values into this equation. So a is 3.6, b we don't know, so we're going to keep that as b squared. C is 7.4. And we can do some of these calculations. So 3.6 squared is 12.96. And 7.4 squared is 54.76. Don't forget to include this plus b squared. So we need to solve for b, so we need to get this term with b on its own. So we need to get rid of this 12.96, and since it's being added to b squared, we need to subtract 12.96 from the entire equation. And then when we do that, we'll get b squared is equal to 41.8. And to get b on its own, we need to use our square root. So when we square root this equation, we're going to get that this is equal to approximately 6.47. So in this case, the steps algebraically are a little bit different. We're just not going to add the square of the two given sides, because this time we know what the hypotenuse is. You're always going to be subtracting the square of the smaller side from the hypotenuse. And now I want you to pause the video and try this next question on your own. Come back to the video when you are ready to check your answer. And here's my solution. I do recommend that you always label your triangle A, B, and C to make sure that C is always your hypotenuse. It's across from that right angle. So once you label it, you can use your two sides and substitute them into your Pythagorean Theorem equation. And then once you solve for your missing side, you should get that it's equal to approximately 9.10.